Hello dear all, I welcome you all in my lecture of three-dimensional geometry. Today we are going to discuss about the topic sphere. Sphere is a very important topic to understand three-dimensional geometry. So let us start our topic here. To understand this topic of sphere, we must know some of the very important things so that we may get all the things, all the mathematical expressions and equations in a very efficient way. So we must understand about three-dimensional planes, circles in two-dimensional shapes, and equation of circle also. So these are very basic things that you must know about to understand the topic known to be as in three-dimensional shapes called sphere. What topic we are going to discuss about in today's lecture of sphere? We are going to visualize a sphere in three-dimensional shapes, analyze the mathematical equations of sphere, and analyze the application of a sphere for better understanding in mathematics. If we discuss about some sphere, so what is a sphere? Can we define it? Yes, of course we can define it. The sphere appears in nature whenever a surface wants to be as small as possible. For example, includes the bubbles, water droplets, some special circles in the nature. They can be represented by C. These are some special type of spheres. So what they are known to be? Z sphere, light sphere, dark sphere, and brass sphere. What is the formation of a sphere? What do you understand how it can be formed? So you know about O was a center of your sphere. P is a point on the surface. Suppose I am giving you some point O that is represented by x0, y0 and z0 as your coordinates of the center, and P is the point on the surface that is given by the coordinate, let's say x comma y comma z. So the sphere can be defined as the locus of the fixed point OP is a three-dimensional shape, is a sphere, and is interpreted by something. Like what? OP. This OP is a distance from O to P, how it can be evaluated. So you have well understand about three-dimensional distances in the last topic, that is called planes. So OP can be given by under root of x minus x naught ka whole square plus y minus y naught ka whole square plus z minus z naught to the power 2. So this is how you can get the values. So this point O is representing you what? This point O is called your center, and P is of some point on your sphere that I already told you. So in the same way, taking a squaring both sides, so you know about that OP is what? OP is your radius. You can just these things that in the last slide that I told you that distance from center to the surface was your radius, that was constant to each and every direction. That means from center to its surface it is a constant distance, so it is represented by letter R. So here I am representing this by a big letter R. So you are getting the value OP as R, and you are getting the same thing without under root after taking squaring both sides. So you are getting x minus x naught to the power 2 plus y minus y naught to the power 2 plus z minus z naught to the power 2 is equals to R square. And this equation is a general equation of sphere, or I can say standard equation of your sphere. This is a standard equation. We will talk about some general equation also. So let us start with some other analysis of sphere. What is the mathematical representation of a sphere? A sphere is defined as a set of all the points in the three-dimensional spaces that are located at a distance r. R means the radius from a given point called the center. The equation of the sphere with center at the origin. That means origin means what? All the coordinates which containing 0 comma 0 comma 0 and the radius r is given by x square plus y square plus z square is equals to r square. The Cartesian equation of a sphere centered at some other point other than 0 comma 0 comma 0 can be given by some equation, and that is already known to you, that x minus x naught to the power 2 plus y minus y naught to the power 2 plus z minus z naught to the power 2 is equals to r square. Let me think about a great circle. What do you think about a great circle? A great circle of a sphere is the intersection of the sphere and a plane which passes through the center point of the circle of the sphere, and as distinct from the smallest circle. Any diameter of any great circle coincides with the diameter of the sphere, and therefore all the great circle have the same circumference as each other and have the same center as a sphere. A great circle is the largest circle that can be drawn on any given sphere. Every circle in the Euclidean space is a great circle of exactly one sphere. So, suppose this is a complete sphere. If I want to cut by a plane, suppose this is a plane and I want to cut it by a plane along its some diameter. So, you will get a circle that will be great. The greatest of the great circle. That means what I am talking about. That means the circle whatever you are getting from a sphere after cutting your sphere by its diameter, you will get a circle that will be known as a great circle. Let us discuss about some facts on the sphere. It is a perfectly symmetrical. It has no edges or vertices, that I can say corners. It is not a polyhedron. All the points on the surface are of the same distance from the center. That means your distance from center to its surface will be always constant. Let us analyze some of the points and some of the facts of a sphere. Any equation of the form a times of x square plus y square plus z square plus 2 times of fx plus 2 times of gx plus 2 times of hx plus k equals to 0 is your general form of sphere. In this form, I can say what is the center and what is the radius. Let us discuss about this part also. The equation can be also written in the another form and is given by x plus f by a ka whole square plus y plus g by a ka whole square plus z plus h by a ka whole square is equals to f square plus g square plus h square minus ak by a square. And this is your general form where you can easily get the value of center as well as radius. So from here I can easily evaluate the center and radius also. So your center is going to be minus f by a comma minus g by a comma minus h by a, and its radius will be your this right hand side, that is given by r is equals to f square plus g square plus h square minus ak upon a square. So this is how you can represent this thing. Let us discuss with some problems on center and the sphere. Find the equation of the sphere with center 1, 1, 2 and that passes through the point 2, 4, 6. Since we are given the center of the sphere in the question, we can plug it into equation of the sphere immediately. So if you have something like x minus 1 ka whole square plus y minus 1 ka whole square plus z minus 2 ka whole square is equals to r square, because your center was given to you in this question, so that's why we can get the values. If I want to get the value of r, the only thing that I want to get the value r, because your center was given, so I can put all the values inside my center. That means the standard form of equation that I given to you was x minus x naught ka whole square plus y minus y naught ka whole square plus z minus z naught ka whole square is equals to r square, where x naught comma y naught comma z naught were your center and your center are given as 1 1 2, so you can put all the values and get your equation of sphere. But the only thing that I need to get the value is radius r. So r will be a distance from your center to the point on the surface of the sphere. So a distance from the center to the point on the sphere can be given by the distance formula, and that is given by d is equals to x2 minus x1 ka whole square plus y2 minus y1 ka whole square plus z2 minus z1 ka whole square inside of under root. So in that case, I can put the value of x2 x1 and y2 y1 and z2 z1. You can take either one of the value as x1 y1, x2 y2 and z2 y2, z2 and z1. Suppose 1 1 1 is your x1 y1 z1 and 2 4 6 is your x2 y2 z2. So by putting all the values, you will get some radius that is given by the distance formula. So it is given by r is equals to under root 26. So in this way you can get the value of r square also. So r square will be going to be your 26, and this way you can get the equation of sphere. Let us discuss over some more equations of sphere and some more concepts on sphere. Suppose you have a sphere whose center is C, that is given by 381, and it passes through the point. And then my question is, what will be your center and radius? Or I can say, what will be your equation of sphere? So you know very well about that standard form of equation of sphere is given by x minus x naught. Here I have written here h, so don't worry about h, k, l. They are all as x naught, y naught and z naught. So that means x minus h to the power 2 plus y minus k to the power 2 plus z minus l to the power 2 is equals to r square is your standard form of equation. So you can put all the coordinates of center that is given to you as 381. So you can put all the values, and by using the distance formula or by using your standard equation that you have obtained from by the center of your sphere as x minus 3 ka whole square plus y minus 8 ka whole square plus z minus 1 ka whole square is equals to r square. Since this is your equation of sphere, so it must satisfy all the points on the surface. So you can put the value of x, y and z as 4, 3 and minus 1. They all are lies inside, that means on the surface of your sphere. So you can put all the values and get the value of r square, and in this way you will get the value and get the equation of sphere. So your equation of sphere is going to be x minus 3 ka whole square plus y minus 8 ka whole square plus z minus 1 ka whole square is equals to 30. Here are some problems to understand the equation of sphere, its center, its radius very thoroughly and very efficiently. So my question is, find the center and the radius of the sphere whose mathematical equation is given as below. I have given you some problems as 2 times of x square plus 2 times of y square plus 2 times of z square is equals to z. How you can find the equation and how you can find the center and the radius? Just by using making perfect square to your x term, y term and z term. Here the only not perfect squaring term of z is of only z, so you can make your z term as your perfect square and get the value. Similarly here also you can get the value of center and your radius. Your center will be minus 1 comma 0 comma 0, and here again you are able to get the value of radius also. Here again if I want to discuss about is your, this is general form of equation, you can get the value of center and your radius, and again for these questions also. So thank you for joining my lecture.